Hey guys, welcome to week 10. So this week you're going to learn about a whole new family of functions called exponential functions. And then in about 2 weeks, you'll learn about the inverse of an exponential function, and we call those inverses the logarithmic function. So an exponential function is going to behave very differently from the linear functions that you learned about in chapter 1. But there are some characteristics that are going to be the same. So let's just recall real quickly what a linear function is from chapter 1. So if you guys recalled, we said that a linear function, right, it has a general formula that's written in the form of some y equals mx plus b, where y is your output value, x is your input value, m is the slope, so it tells us how the function increases or decreases, and then b is the initial value, or your y-intercept. So a linear function is a function that either increases or decreases by a constant rate of change, and we call that constant rate of change the slope, okay? When you start learning about exponential functions this week, exponential functions, they increase or decrease by a constant percent rate of change. So it sounds like a linear function, but the key difference is that that change for an exponential function is always a percent increase or a percent decrease. And it also has its own general equation. So the general equation for an exponential function is always y is equal to some a times b to the x power, okay? Where y is your output value, x is your input value, and then you'll also see that most of the time, instead of using an input value of x, we use the variable t. Just because exponential functions, most of the time, we're talking about data that increases or decreases over time. But again, you've got your output value and your input value, and in this equation, a is your initial value, so it behaves like the b value for your linear function, and then b in an exponential function, b describes how the function increases or decreases. So b is going to tell you if that exponential function is increasing by some percent or if it's decreasing by some percent. So you're going to learn how to write these equations for exponential functions, and then you're also going to be comparing exponential growth and decay to linear growth and decay. So please email me if you have any questions as you're working through this week's lessons, or schedule some office hour time to come see me individually. Okay guys, have a great week. I'll talk to you soon.